Hey everyone, in this video we're going to go through the Vigenère Cipher. So from previous knowledge you may know that encryption is the process of converting a plain text into ciphertext form, and decryption is the process of converting ciphertext back into plain text form. Now the Vigenère Cipher is a method which we can use to conduct both encryption and decryption operations on messages. It is essentially a polyalphabetic cipher which uses a key and a series of modulo calculations for encryption and decryption. So we're going to learn how we can use the Vigenère cipher to encrypt a message through an example. So we're given a plain text hello world, and we've been asked to encrypt it using the Vigenère cipher and a key move. So the first step in the encryption process is we assign numeric values for each character. So because the plain text and the key both use letters and there's no numbers or other characters, we assign a numeric value for each letter in the alphabet. So we start at A is equal to 0, B is equal to 1, C is equal to 2, and so on until we get Z is equal to 25. Now, in step 2, we must finalize the key and convert all letters to numeric form. So to finalize the key, we must make the key the same length as the plain text. So the plain text over here is 10 letters. This plain text is 10 letters. However, our key is only 4 letters. So we must repeat our key until we match the length of the plain text. So we add another move, M-O-V-E and M-O. So now we've got a finalized key because it's the same length as the plain text. They're both 10 letters. So now we must convert each letter in the plain text and the key into numeric form. Now we do this by referring to the table we just made here. So we know that H is equal to 7. Hence we convert H to 7. So we write H is equal to 7. E is equal to 4. L is equal to 11. And so on. We convert each letter and we get these results. So this is our plain text in numeric form, and this is our key in numeric form. So we define the numeric version of our plain text as P of I, and the numeric version of our key as K of I. So now we move on to step number 3, where we calculate P of I plus K of I. So to get P of I plus K of I, we must add the plain text numeric form to the corresponding key in numeric form. So we get 7 plus 12. We get 7 plus 12 and it equals 19. We get 4 plus 14 and it equals 18, and so on for all the numbers. And this is P of I plus K of I as a result. So now we take this and we move on to step number 4, where we actually calculate the ciphertext. Now the formula to calculate the ciphertext is P of I plus K of I, which we just did, and we take the mod 26 of that. Now we take mod 26 because there's 26 letters in our alphabet sample, starting at A is equal to 0 and Z equals 25. There's 26 total samples, which is why we take mod 26. Now, we just did this calculation, P of I plus K of I, in step number 3. Now we just take mod 26 of it. So 19 mod 26 is 19 itself. 18 mod 26 is 18 itself. 32 mod 26 is equal to 6 here. 15 mod 26 is equal to 15. 26 mod 26 is equal to 0 because there's no remainder. And so on until we've calculated mod 26 of each of these numbers. And these are all the solutions from it. So this is our ciphertext. We must now convert this into letter form as shown in step number 5. So this is where we derive the actual ciphertext in letter form. We take these numbers and we refer to the first table we made and we convert them into letter form. So 19 in our table is equal to T. Hence, our first letter of the ciphertext is T. And we do that step for each of these numbers, and we get our answer here. This is our answer, This is hello world converted into ciphertext form using the key move and the Vigenère Cipher.